Here we're going to be discussing factoring binomials. Binomial being two terms, seeing 4x squared negative 9, 16x squared and 9, and 8x cubed minus 27. All of these having two terms. Now there's three types of these that you could possibly see. The first type that we can factor is called a difference of two squares. That being 4x squared and 9 are all perfect squares and a minus sign in between, that giving us a difference of two squares. Now all of these are going to factor into two binomials. Binomials meaning there's going to be two terms in each of them. Now what's going to go in each? Well, it's just going to be the square root of every term inside. So square root of 4 is 2, square root of x squared is x, square root of 9 is 3, and that's going to be the exact same thing over here, a 2x and a 3. The only difference is that they are going to have opposite signs, a plus sign and a minus sign in between. And that's how we factor a difference of two squares. For sum of two squares, sum of two squares, meaning everything in here is a perfect square, 16x squared and 9, and sum, meaning there is a plus sign in between. If you ever see a problem like this, it does not factor. This is not factorable. That is very important to understand. Many people want to say that this factors to, again, 4x plus 3 squared. That is not the case. This does not factor at all. Now our last type of binomial that we're going to factor is called a sum or difference of two cubes, meaning everything inside here is a perfect cube. 8 is a perfect cube, x cubed, perfect cube, and 27 is also a perfect cube. Now this is going to be slightly different than the one that we factored up here. This is going to factor into a binomial where we'll have two terms times a trinomial where we'll have three terms. Now if you remember, there is a slight song that we have to factor this. Not going to sing in this video. So I will talk through how we're going to factor this. So in this first binomial, we are going to put the cube root of every term. So cube root of 8 is 2, cube root of x cubed is x, cube root of 27 is 3. So cube root, take the same sign, minus. Now to get this trinomial, we're going to work with these terms here. So to get the first term, we are going to square it. So squaring 2x is going to give us square 2, 4 square x, x squared. And square our last term, squaring negative 3 is going to give us a positive 9. Now to get this middle term, we are going to multiply these together and take the opposite sign. Opposite sign being a plus, multiplying them together to give us a 6x. Again, what do we do here? Cube root, take the same sign. Square it, multiply them together, take the opposite sign. And that is how we solve sum and difference of cubes. Now, what I have here are two example problems that I want you to try. I would like you to pause the video, solve both of these, and then once you're done, hit play, and I'm going to explain how to solve both of these problems. Okay, hopefully you have time to factor both of these. In example 1, we have what we've had up here, a difference of two squares. Again, difference, minus sign, and everything in here is a perfect square. So this is going to factor into two binomials, and I know that they're going to end up one being positive, one being negative, and same terms in between. What are those terms going to be? The square root of each of those terms. Square root of 9 is 3, square root of x squared, x. Square root of 25 is 5, and those terms are going to go in both. 3x plus 5, 3x minus 5. Very important that you have opposite signs, but they stay the same. For this over here, now I notice I have a sum. Is this a sum of two squares that is not factorable? No. 64, yes, is a perfect square, but I have an x cubed and a 125. This is going to be a sum of cubes. So, as I recall, this is going to factor into a binomial times a trinomial. So, to factor this, cube root 4x, cube root 5, take the same sign. Over here, square it, 16x squared, square it, positive 25, multiply them together, 20x, take the opposite sign, minus. And that is how you solve